talk about modeling quadratic functions, 4.3. Modeling, remember, it means that we are writing equations to fit real life data. Now, if you recall, back in geometry, you needed 2 points to make a line, right? So how many points do you think we need in order to make a quadratic? 3, yes. We need 3 points. It has to be able to show that it's turning, right? All right. Now, just like we did before, this is what we're going to do today. You are going to go into Stats, into Edit. Oops, Edit. Helps if I spell correctly. Edit. I know. You're going to go into List 1 and put your X values. You're going to go into List 2 and put your Y values. You're going to go back into Stats. Push over to Calculate, and this time we're going to go down to Quad Reg. It's going to come in standard form. Remember, standard form is y equals ax squared plus bx plus c. And it is going to give you your a, your b, and your c. So you're writing the equation. So if you learned how to do the line reg the last time, this is easy because you already know how to do it. You're just going down one more spot when you go into Calculate. All right, so here we go. We're going to do example number 1. This is exactly, well, what you are doing for most of it, but we'll break it down a little bit more. Let's say 8 through 14. No, not really. No. Find the quadratic function through. Here are our points. Let's go with negative 1, 6, the point 1, 4, and the point 2, 9. All right, so you're going to go into Stats, into Edit. List 1 should be negative 1, 1 and 2. List 2 should be 6, 4, and 9. Once you get those in List 1 and List 2, you go back into Stats, over to Calculate, and down to Quad Reg. Very good. But you have to write it in the equation, not a, b, and c. So we're going to have y equals 2x squared minus x, because it's minus 1x, and then plus 3. Okay? So it gives you your a, b, and c. You are putting those in the equation in standard form. Any question? No question. Anybody at all? Okay. All right. As I said, if you learned it before, this should make it really easy. Let's go to example number 2. Pretty similar to this. Example 2. I'm going to call this 18 through 20. Again, find the quadratic through. This time it's written like this. F of 0 equals 5. F of 2 equals 3. And F of negative 1 equals 0. So let me talk about what this means. If you look at this notation, F of 0 is really F of, this is usually our x value, right? And this whole thing is equal to 5, which means 5 is actually your y value. So really you already have these points. This is 0, 5. This point is 2, 3. And this point is negative 1, 0. So you're going to go back into stats. In list 1, now you are putting 0, 2, negative 1. In list 2, you are putting 5, 3, and 0. Go back into stats. Over to calculate. Down to quad reg. Yep. So we get y equals negative 2x squared plus 3x plus 5. The only thing different in this is how they wrote the points. How they wrote the points is typically how you will see it on the SAT. That's what this means, is that's the x value, that's the y value. That's all that means. Okay, it's just a point written differently. Any questions so far? Okay, so let's get into a real life situation then, all right? Let's get into a real life situation. Example number 3. Example 3. Find the quadratic function for the data, then predict, whoops, the price in 2030. All right, here's our table. What? Well, all right, so let's go start with the year 2010. In 2010, the typical cheeseburger at McDonald's is what, $1.49 maybe? Oh, sure you can. In 2015, the price goes up a little bit, let's say to $1.79. Actually, you know what? Let's say the price is going to drop. Let's say it goes down to $1.29. Yeah. Right? How about in 2020? It's right around COVID hit, so let's say $1.09. So let's say then in let's go 2022. Right now it's what, at $2.15? $2.15. All right. So here are our 4 points. Now, first of all, one of the reasons I wanted to do this problem is to remind you when we did it with linear, what was special about the years when we put them in. Yes. So this one's going to be 0. This happens 5 years later. This happens 10 years later. This happens 12 years later. And once we get our equation and we go to predict 2030, what number am I going to put in? 20. It is 20 years after our start. Okay? So now everybody grab their calculator. We're going to put these in. Yes, that's your x value. Time is always your independent. Oh. Yeah. Sure. A second. Let me get this up first. Okay. Yes. Yeah. How bad? Depends. Sometimes it's really bad. Oh, on to quadratic. All right, now that I got my equation. Okay, so I want to put my equation up here, see where I'm at. I'll be right back there, you guys, just a second. Okay, so this one, we have y equals, I got 0.0183 x squared minus 0.19x plus 1.556. Do you guys get the same thing? Yes? Okay. So now we want to predict by plugging 20 in for our x value. So 0.0183 times 20 squared minus 0.19 times 20 plus 1.556. You guys tell me, as soon as somebody finds out how much our cheeseburger is going to cost in 2030. No, that's not what I got. Did anybody else plug it in? 507, that's what I got. $5, and yeah, if you round up, it's going to be $5.08. So we use this to predict, right? That's the whole idea. Last thing I want to talk about real quick, and I'm going to go back there and help them, and you guys can start on the homework or start on your Desmos activity. On number 22, when you get to that one, the book gives you a table, okay? Are you guys listening? The book gives you a table, and this table in number 22, it has number of points, and then it has segments. And it starts off by telling you 2 points makes one segment. So if I had 2 points, there's only one way I can connect them, right? Then the table says if I have 3 points, there's only 3 segments that can connect them, right? But then they want you to fill in the next 2 of the table. So you're going to go 4. If I have 4 points, I have 1, 2, 3, 4, 5, and 6, right? So now you have to figure out 5 and then write your quadratic function. Okay? That's what it means in the table. I just wanted to clarify that. Yeah, you're welcome. Yes.